So this is my solar cooker for AP Environmental Science. I started with a styrofoam cooler so it stays insulated. I then cut off the top of the cooler using a knife, added saran wrap to the top of the cooler so it kind of acts like a greenhouse. Then proceeded to add tin foil to the inside of the cooler and porcelain dishes which I'll cook in. This is what your final result should look like. Solar cooker. So what I did is I took a old styrofoam cooler, and then I cut off the top of the styrofoam cooler and I put some saran wrap on it right here. Inside I laced it all with tin foil so it reflects all the heat, and the cooler will insulate it. I put 2 metal dishes in there to cook when it's ready. Right now it's been heating up for about only 15 minutes and it is already up to around 160 degrees Fahrenheit inside, so that's good. We'll wait probably another 10-15 minutes and then we'll cook eggs in it. Alright, so this is my solar cooker. We have 2 porcelain trays in there, or dishes to cook our items in, a thermometer to measure the heat. We're going to be cooking some ground turkey and an egg. So we'll put it in there and we'll time ourselves, see how long it takes to cook. And then we're going to close the top, make sure it's tight, adjust it so it hits the sun good, and we wait. So it's been about an hour, and a lot of condensation, so that's good. The moisture from the stuff is coming off. Right now the meat's starting to change color and juices are coming out. The egg hasn't really changed though. And that's doing good. After about another hour, the egg was cooked, and so was the meat, cooked all the way through. It took about a total of 2 hours and 15 minutes, about an hour to heat up the solar cooker, and another hour and 15 minutes to cook everything. With my solar cooker, I tried to keep eco-friendly in mind, so I was reusing the styrofoam cooler that we found in my basement, so it would reduce less materials than going out and buying a styrofoam cooler. Just thinking all about the reduce, reuse, recycle. I recycled all the saran wrap when it was done. You probably could find more eco-friendly materials, but that's what I had in my house. Some changes I could have made in my solar cooker, like this design shown, is I could have put like the aluminum foil on the outside of the solar cooker so the light reflects in and then have a black inside. So not only will the styrofoam insulate it, but the black will absorb all the heat and keep it like pretty much an oven. My aluminum foil was on the inside, so it was just kind of reflecting around, maybe not getting to its full potential of heat. But other than that, I thought the solar cooker worked very well. As far as my materials, I spent zero money on all my materials. All were fine in my house, just lying around, or we've already used them before. So how my solar cooker kind of pertains to the environment and AP Environmental Science class course. Well, it's not producing like any CO2 emissions from burning off gas or coal, say from a wood or a gasoline stove, and it's using solar energy. We're also reusing our materials and recycling our materials so we have less input on waste. But mainly focusing on, like, let's say a developing country who can't afford the proper materials to, let's say, cook food. To have proper nutrition, this is another alternative to kind of reuse materials that are not very expensive or cheap. Recycle and reuse the materials to build cookers to cook food so they don't have to eat from raw or not eat at all, let's say. Also in our own country, for people who necessarily can't get that nutrition from cooking their food and they had to go buy, unhealthy options or just eat from raw, which isn't healthy, they can now cook their food with a reused and cheaper alternative that produces less waste in the world, one, and it also benefits the world in another.